students. Today I would like to explain design for fluctuating load, that is from unit number 3rd from the subject design of machine element 1. So let us start with the first point is stress concentration. Students, stress concentration means what? It is defined as the localization of high stresses due to the irregularities present in the component and abrupt change of cross section. The irregular shapes means what? There are some discontinuities present in the plate or in the component, such as oil holes, grooves, keyways, steps, splines and screw threads. These are the discontinuities present in the component due to which stress concentration occurs. The diagram shows the plate having tensile stress sigma T, and in the second diagram it shows that the stress concentration sigma max means what? Stress concentration is acting due to hole present in the plate. Then students, next important parameter is causes of stress concentration. What are the important causes that due to which stress concentration occurs? So first important parameter is abrupt change of cross section. This abrupt change of cross section is due to what? It is due to keyways present in the shaft, then steps, grooves, splines and screw threads found in the shaft. Second important parameter is poor surface finish. Third is localized loading. Localized loading in the form of it is the contact between the meshing teeth of the driving and the driven gear, then contact between the cam and follower, then contact between the balls and recesses of the ball bearing. Next is variation in properties of material. For example, in design of machine component, it is assumed that the material is homogeneous throughout the component. Means variation in material properties due to internal cracks and blowholes, cavities in welds, air holes in steel components, non-metallic or foreign inclusions. And fifth important parameter for stress concentration is machining scratches. Machining scratches, stamp marks or inspection marks are surface irregularities which cause stress concentration. So these are the 5 important parameters due to which stress concentration occurs. Then next students, important parameter is methods of reducing stress concentration. There are 3 to 4 methods are there to reduce stress concentration. So we'll discuss one by one. First parameter or first method is additional notches and holes in the tension member. Figure A, B, C and D are here. It is given. This figure A shows the plate having notch, means this is a normal figure or normal stress concentration due to notch is original notch provided to the plate. This figure A shows there is some stress concentration occurs due to single notch provided in the plate. Then we have to reduce that stress concentration by providing multiple notches, that is shown in figure number B. In figure number B, this arrow lines means what? These are the flow lines. In figure A, by comparing figure A and figure B, it shows that these arrow lines are getting straighter or that edges are straight. Figure C shows the blowholes or multiple drill holes are provided on the plate, due to which stress concentration reduces, means that arrow lines are getting straighter and straighter. Then next is removal of undesired material from the plate. Figure shows the removal of material below notch, due to which stress concentration reduces. So this is about reduction of stress concentration due to phi notch, that is from figure A it is original notch, and we have to reduce the stress concentration by providing figure B multiple notch, figure C multiple drill holes, and figure D by removal of undesirable material. Second uh, method is fillet radius undercutting and notch for members in bending. For example, figure A shows the circular bar having shoulder and the stress concentration, this line shows the stress concentration occurs due to abrupt change of cross section, that is due to sudden corner. We have to reduce that stress concentration by providing fillet radius, it shows in figure number B, and figure number C shows by providing undercut to the corner, and figure number D shows by providing notch to the circular section. Figure shows the reduction of stress concentration due to abrupt change in cross section, that is original component figure A. B shows we have to provide fillet radius R, due to which stress concentration reduces. Figure C shows we have to provide undercut at the notch, undercut at the corner, that's why stress concentration reduces, and figure D shows addition of notch. Next method is drilling additional holes for shaft. Figure A shows normal shaft, that is original shaft having keyway, and due to which stress concentration occur. So figure B shows we have to reduce that stress concentration by drilling holes to the shaft, and figure C shows we have to provide fillet radius to the shaft so that stress concentration reduces. Next important parameter is reduction in stress concentration in threaded member. Figure A shows threaded member having stress concentration. How to reduce that stress concentration in threaded member? Let us consider figure B. In figure B shows we have to provide undercut to that threaded member, due to which stress concentration reduces in threaded member. Also in figure B it is observed that by reducing shank diameter to the threaded member, stress concentration reduces. That line shows, there is a straight flow line shows that the stress concentration is reduces due to reduction in diameter, that is shank diameter. Next important factor to study in this unit is stress concentration factors. So there are two important stress concentration factors: theoretical stress concentration factor and fatigue stress concentration factor. So let us discuss one by one. First, this stress concentration factor is used for ideal materials that are homogeneous, isotropic and elastic. So let us start with first theoretical or geometric stress concentration factor. It is defined as the ratio of maximum stress in a component, means at the discontinuity, to the nominal stress at the same section, means it is the ratio of sigma max to the sigma O or tau max to the tau O, that is Kt equal to maximum stress upon nominal stress. Plate shows the circular hole at the center and having tensile force P. By applying tensile force P, the hole due to discontinuity, stress concentration is acting, and that is sigma max is the maximum stress and sigma O is the nominal stress is acting in the plate. The magnitude of stress concentration factor depends upon the geometry of the component. Second important parameter is fatigue stress concentration factor, that is K suffix F, that is fatigue stress concentration factor. What is fatigue stress concentration factor? It is defined as the actual maximum stress in notch specimen to the nominal stress in notch free specimen. Means what? Kf equal to actual maximum stress in notch specimen to the nominal stress in notch free specimen. And the factor Kf is applicable to the actual material and depends upon the grain size of the material, and also the value of Kf is lower than the factor Kt. In actual loading, especially fatigue loading, the effect of stress concentration is usually less than that predicted by theoretical stress concentration factor. Students, these are the stress concentration factors, and also we have already discussed about methods of reducing stress concentration and the causes of stress concentration and what is meant by stress concentration from unit number 3, that is design of fluctuating load. Thank you, students.